Okay, hi everyone. So yes, I'm Adam Rowe. I'm going to be talking about generational performance improvements within Lustre. So as I'm sure you know, a lot has changed over Lustre in the past basically year, from basically last year to today. There's been a significant change in terms of the amount of features and things going into the file system. So I wanted to look at how the performance has changed over time, specifically focusing more on ZFS, but maybe look at LDiscFS as well. So when I walked into this, I wanted to look at performance comparing with last year, because last year I did a talk here at LAD talking about basically DNE performance. I spoke about ZFS, LDiscFS, scalability, and also the overall performance. So I wanted to revisit that and see where we are today versus where we were previously. But then again, there's also new features in Lustre as well, such as things like progressive file layout, data and MDT, which I wanted to visit. I've talked about progressive file layout, but I wanted to talk about data and MDT, but I didn't quite get time to run the benchmarks. So let's start off with looking at some hero numbers, let's say. So basically, very much like the previous talk, some very, very high metadata performance. What does it look like today versus yesterday? That includes basically just generic metadata performance, but also looking at things like small files as well. And also LDiscFS. A lot of what we just saw was kind of LDiscFS in the future, upstream kernel and a few patches which have yet to land. So this is basically looking at LDiscFS with Lustre 2.10 versus Lustre, one in effect, the one I ran on was Lustre 2.9 EA, which was, I'd say, a cutting edge version of the 2.9 release at the time. Maybe look at some DNE phase 2 performance, then also does PFL actually affect performance? So progressive file layout is one of those new features that came into Lustre 2.10, and new features in a file system, these things need to be tested, these things need to be understood. So it's a case of looking at what PFL does, and does it actually give you a tangible performance boost and usability increase on your file system. So last year's talk, I talked a lot about DNE last year, but I didn't have any LDiscFS numbers. So I wanted to briefly revisit some of those numbers and show you kind of some of the performance I achieved in LDiscFS, scaling with DNE phase 2, just to cover off some of the opens from last year. And maybe also talk about some of the scalability implications. And also DNE 2 in production. There was a lot of hesitancy around DNE 2, which was released in Lustre 2.8, and not many people were adopting it in a production environment. Back then I said I was using DNE phase 2 in production. At the time was only for a few months, and now I've still been using it in production for over 18 months now on what was basically a Lustre 2.8 release. So that's still going well, and it's very stable. So to make things as comparable to my benchmarks last year as possible, I tried to keep the test bed consistent. So basically the hardware is identical. The only thing that's changed from last year is essentially the kernel and also the Lustre version on the server side. There might have been some improvements in the network stack. There's a new Intel OmniPath release on there, but essentially the hardware is the same. So it's a combination of NVMe storage servers and 16 compute nodes. Overall, it's extremely fast file system, not very high capacity, but it's literally designed for running benchmarks essentially, not really any production use. Again, some information about the hardware architecture. Again, nothing to shout about. V3, V4 CPUs, and some Intel SSDs. So why are we doing this? So Lustre itself is, if you look way back in the past, Lustre has traditionally been that HPC file system. A lot of people, from my experience in the field, I'm seeing a lot of people use Lustre for things other than traditional HPC. So genomics may be not in that space. It just mentioned things like AI, machine learning, data analytics, and other workloads are being used on the Lustre file system. So you're seeing people with these kind of mixed workload, mixed usage clusters who want a file system that can address several use cases. We saw the very interesting talk about Lustre with OpenStack to see what you can actually do with this single file system instead of just HPC. So it's important to note this is the graphs you're going to see are going to be comparing essentially some of the data from last year with some data I ran this year versus Lustre 2.9 basically early access and Lustre 2.10.1. There'll be some kind of iterations of 2.10 thrown in there just to kind of show you some generational performance scaling, but I'll cover those when I get to them. So there's a lot of information to look at there. So let's just look on the left, very far left-hand side right now. You can see, well, for high level, this is MD test, metadata performance. Very left-hand side, you can see Lustre 2.9 was ZFS 0.6.5. This, at the time, was basically the fastest release you could get with ZFS that was anywhere near production stable. ZFS RC 07 RC1 was available, but that was, very, very early. So we were looking about 5,000, 6,000 file creates on a ZFS-based Lustre MDT, which, compared to at the time LDiscFS, was pretty poor. People were starting to adopt ZFS because of the new features you get with it, but overall the metadata performance was one of the biggest complaints. At the time I ran some numbers on RC.1 for 07 RC.1, and the performance improved quite nicely. There was a bit of something like a 3x performance boost going to that release, which was at the time very exciting and very nice. However, it was still very far away from what LDiscFS could achieve. I ran some numbers again, probably in the July-June timeframe on what was Lustre 2.10 plus ZFS 07 RC5. This was, I think it was in fact early release of Lustre 2.10, and again it's showing good improvement in the performance of metadata. So we can see again a nice bump up to around about 37,000 file creates per second on OpenZFS. Compare this to at the time LDiscFS was about 50,000. So at the time we're getting very, very close to the comparable performance between ZFS and LDiscFS on metadata performance. Fast forward to today, Lustre 2.10.1, the release which just came out, plus ZFS 0.7.1. This is where we're at right now with OpenZFS and Lustre performance. So you can see here we have anywhere in the region of between about 50 to 55,000 file creates per second, given a bit of margin of error, versus what at the time was about 50, well, versus my previous results, which were about 50 to 60,000 file creates in LDiscFS. So the performance was, I would suggest, very comparable. I then became aware that there was lots of efforts actually going into not just OpenZFS performance, but also LDiscFS performance, and improving the metadata performance generally across Lustre. So I wanted to rerun some numbers to look at Lustre with LDiscFS, and not just ZFS, and see how the metadata performance improved. So I'll talk about that in a little bit, but we'll table that for now. But overall, you can see a good generational performance improvement between where we were yesterday to essentially where we are today with OpenZFS. So I think from a adoption usability perspective, this is really the key indicator that ZFS is the one main complaint most people had about ZFS is pretty much gone away. So it makes it more accessible and more less challenging for people to adopt in their environments. Again, you would expect this to be quite similar based on the previous numbers. This does take into account some DNE, distributed namespace, but again, I'll look at that in some more detail a bit later. But essentially what we have here is small file performance. So again, not quite 0-byte files, but 4K files across multiple MDTs. So in this case, we have 1 MDT per MDS, 8 MDSs, 8 MDTs, comparing last year's results to this year. We have file create and file remove called out there. And performance is pretty consistent. I mean, if you look at the relative scaling, it's pretty much unchanged, but the overall number is higher. So again, we're looking at anywhere in the region of about 50,000 file creates, scaling up to, well, in this case, about 200,000, then flattening out. This is a limitation on the hardware that I had. I didn't have enough clients to saturate that much I/O. I couldn't put enough I/O into the file system, essentially. So it's a good demonstration to see that it is scaling and it is progressing as a file system kind of year on year, version to version. Okay, so I'm going to touch on LDiscFS very briefly. I know it was covered quite a bit before, but I just wanted to talk briefly about how that's changed since we spoke last year. So again, a lot of graph to look at, but let's look on the left-hand side. So 56,000 file creates. This was this time last year where we were at with LDiscFS metadata performance on this particular platform. Obviously it's relative depending on your hardware, but at least my test platform, that's where we were at, which is a pretty reasonable number. There's nothing to say. This is comparable to where we are with ZFS today. But over time, things have slightly changed. So again, the biggest change that I was most impressed of is Lustre 2.10 versus Lustre 2.10.1. So there was a patch that landed in Lustre 2.10.1 that did improve the file create performance, well, metadata performance on Lustre. So it actually gave us a big boost in performance, going from 80,000 file creates to 125,000 file creates on the same hardware, basically the same test platform. I didn't really believe this when I first ran it. I ran it several times over to check that it was actually right, and it was the case. So whoever worked on LU7899, good job. It was very, very nice to see this. And again, this proves that LDiscFS, isn't dead. There's a lot of development going into both branches of Lustre, and people want to see both of them succeed because, again, there's pros and cons to both, right? So, briefly touch on DNE phase 2 scaling, because I didn't actually have any numbers from, LDiscFS last year, so I wanted to briefly touch on them and compare the scaling today versus previously. So I've normalized the results here to compare last year's scaling with this year. So in the gray, you can see the essentially linear scalability. The blue, we have the Lustre release last year, and we have the Lustre release today. The scalability overall has dropped a little bit. It's not the end of the world. I mean, if you look at the overall absolute number, it's much higher compared to before. I mean, we're talking kind of 8x before versus the previous year. So I would probably attribute some of the degradation to that. However, overall, I'd say it's reasonably okay. Again, I think some work needs to be put into this to get the scalability to a similar level to what we see with OST scalability today, which is pretty much linear, OST and OSS scalability, but hopefully some work can be done in this area to make sure we can increase the scalability of DNE. Again, it does show a nice level of scalability, but it's not quite as linear as we'd like. So let's briefly look at LDiscFS. I'll only touch on this very briefly because, as from the previous slides, you saw that basically the absolute number I could hit was about 220,000 file creates from my clients. So pretty much I saturated my file system, well, I saturated my clients after 2 MDTs. So basically anything after 2, totally ignore because it was flat due to the amount of clients I had. If I had more clients, I would expect to see a similar level of scalability to what we saw with ZFS. But again, I need to throw more clients at it to understand if that's the case. But 1 to 2 at least is showing a good level of scalability. 125,000 file creates to about 200. Excuse me, I'm recovering from a cold. So a bit that I had kind of last minute, so I wanted to briefly talk about PFL. So when progressive file layout came out, I was extremely happy as more, not from a kind of Intel perspective, but more from a consumer perspective, because it meant that I didn't need to worry about my stripe layouts anymore. I didn't need to worry about where I put my data, how big it was, and any stripe configuration. So I won't talk about what it is because I'm sure you're relatively familiar, but this is the example test case I used. I just wanted to demonstrate how using PFL can just simply make your life easier and get more out of your system. So I configured what was essentially a 6-stripe configuration. I missed, there's meant to be a 32 stripe at the end, but I missed it off the diagram. So six basically parts of the layout, 4 meg, 64 meg, 256, 1 gig, 10 gig, and beyond. Again, example of what the layout looks like. Again, those of you who've used LFS set stripe before will probably look somewhat familiar to you. Again, you can see the different, where we're looking here, strike count on the left-hand side as part of the single layout. Again, Gabriele covered some of this off yesterday. So, I wanted to just show, essentially, because I was expecting maybe to see some slight degradation in performance when using PFL. I thought there might be some sort of overhead. So this was the kind of main motivation for that. I actually saw the opposite. I actually saw a nice performance improvement for what I expected to be a very stable workload. So I ran IOR twice. I created 2 directories, one with a -1 stripe, so stripe all. Another one with the layout you saw before. I then used IOR with file per process run, 256 processes, 256 files, each 16 gigabytes each. So obviously as the file grows in size, it gets stripe wider, so 1 meg, 4 meg, 256 meg, and as you saw before. So read performance was consistent. I was quite happy that read didn't change, again, as you would expect. Write performance actually improved slightly. I would generally put this down to the more optimized configuration depending on the file size. So again, your results may vary, and I would like to have tested this on a wider variety of benchmarks and file sizes. So maybe look at some small files, lots of files, various different configurations. But again, limited time, I only thrown through these in the last minute. This was kind of where I'm at. So I wanted to look a bit beyond this and see if I could optimize a bit further, because not only can you change the stripe counts in PFL, but you can also change things like stripe sizes. We can probably make the assumption that if you start going up to kind of 16, 32 and beyond stripes for your file, you can probably assume that file is reasonably large. So you could maybe make your stripe size larger to best kind of get better performance from the file system. So in this case, I modified the stripe size. So for the first one, I kept the default of 1 meg. Went up to 2 meg, 16 meg, 32 meg, 128, 256 meg. I didn't want to go too big, but again, you can, depending on your workload, your file system, I changed the striping slightly to better optimize. Because as I said, if your file is striping to that many OSTs, you can probably make the assumption it's reasonably large. So taking this into consideration, you can actually see you get again, more performance improvements. If you compare the gray bar with, let's take the orange bar in this instance, the no PFL, basically an optimized layout for your file versus a pretty much standard configuration. I mean, if you've got an environment computer center where your users don't necessarily know how to use Lustre, they don't want to know how to use Lustre, they just want a file system to write data, you probably set a stripe size which is best guess. A stripe size, stripe count, best guess for the workload, maybe 4, 8, depending on the workload, the department, the use case. This is basically giving the flexibility to not have to worry about any of that. You can set a predefined layout and all your problems are solved, essentially. So you can see here the same workload using a slightly optimized configuration with stripes count and stripe size is giving us a significant performance improvement. If someone told you you could get near 10% performance improvement on your file system without doing anything, I think people would probably take it. So again, just something to think about when looking at moving to a new release of Lustre and the sort of things that are available in Lustre 2.10. So just to summarize, small file performance is just generally better. I was extremely pleased with the performance we've seen year over year, well, from last year to this year, both ZFS and LDISCFS. It's been excellent work, and whoever, all the developers who've worked on OpenZFS, I think have done a fantastic job getting OpenZFS 0.7.1 to where it is today. It really makes it a very compelling option for your Lustre file system versus an alternative LDISCFS solution if you want to look at things like encryption, compression, and all of those other things you get with ZFS. DNA phase 2 scalability is pretty much the same, but again, there needs to be some work going into that to really bring it up to the level where we see OST scalability today, because again, with workload shifting, things like data and MDT coming along, people are going to start to want more MDTs and bigger MDTs. So we need to make sure we can scale that MDT count out, the MDS count out, to make sure that we can take advantage of all these new features and new workloads that are coming to Lustre. And finally, striping, I think the results were quite clear. I just basically put a layout and the performance was better. So if you have the option available, and again, if you can get that performance boost without really doing anything, it takes a lot of burden off you and a lot of burden off your users to understand Lustre. So finally, if you take anything away from this, if you've fallen asleep, generational performance improvement, LAD 16 to LAD 17, LDISCFS is up 2.2 times, and OpenZFS performance is generally up about 7.7 times. So basically a very, very healthy, positive change within the Lustre file system. And that's it from me. Thank you.
Thank you, Adam. I'm really happy to see, if you can just show the last slide, to see that LAD is so effective in Lustre performance. So I really want to be for lab 18. I mean, the numbers will be really cool. So you see that lab is really nice for Lustre. So does somebody have some interesting question instead of my silly comments?
As I see, you have a testing for DNA and it have no scale after 2 MDTs. Did you use single directory for all MDTs? Or
So this scaling here was, I mean, I explained at the time, I hit 200,000 file creates after 2 MDTs. I only had 16 clients. My clients weren't able to generate any more I/O.
So
that was the limitation.
So you stop.
That's why.
Right. Did you try to create several Lustre mounts on client to generate more loads?
I didn't try several mounts, no. But I did. But I mean, if I go back to this is ZFS scaling. The overall performance is lower, so you can see it scales further. But again, this was a limitation on hardware that I had available, not the actual performance of DNA Phase 2.
What is the actual ZFS performance?
Yeah, it's back one slide.
Yeah.
Yeah, but there aren't any. There isn't access with.
This one. Oh, for DNA or ZFS?
Yeah, the DNE ZFS.
DNE.
Please, thank you.
Here. Yeah.
This is
Is that the same
small
thing?
file.
Oh,
The other one here is this one
yeah.
you're talking about.
What are the units on
That's
this?
relative. I normalized the performance
Okay.
because they were so different. So LAD 16, the previous release, it was like 5,000 file creates per MDT versus 55,000. And you know, I didn't normalize it to start with. I put it on a graph, and it's very uninteresting. It's just a flat line plus for before and a nice line for today. So you didn't really get any scale or relativity.
So have you run the MD test on the single shared directory rather than the unique directory?
For which benchmark?
Or
Well,
MD
for which?
MD test?
Yeah, for which test case?
Any case. So all of the benchmarking seems to be the unique directory
Unique
operation.
directory,
Way.
yeah.
Did you run the shared directory operation?
Not recently. I did on my previous testing, but not recently.
No more question? Thank you.
Thank you.
Thank you very much.